Okay, hello, welcome back. We are going to do one more numerical. It is based on de Broglie's uh, wavelength, and it is also dependent on the application of Heisenberg uncertainty principle. So the question is, it's about finding the energy of neutrons. So we are going to find the energy. So one thing is certain that we are going to use this formula. Okay, so when you start looking at a problem statement, start writing down whatever comes to your mind in the first place itself. Okay, because no one knows how to solve a numerical. Your brain would solve it, and you have to help it in solving that, and the help would come in the form of visuals. So you have to show your brain whatever information it has. So it is quite interesting thing that brain would start working once you tell once you show it visually what it already knows. So it is like Hanumanji. So you have to keep reminding your brain what it is capable of. You just have to be the Jambwant and help it uh, by telling it what it already knows. Okay, anyway, so the question is find the energy of neutron in electron volt. Okay, so we have been given a neutron. So the fact about neutron is it doesn't have any charge. So the only fact that you know about neutron is it has a mass. So mass of neutron is 1.67 into 10 to the power minus 27 kg. This is the fact that you know. And you have been given the de Broglie wavelength of this neutron is 1 angstrom, that is 10 to the power minus 10 meters. Okay, so we can start from here because we have to find out energy. So we do have mass of neutron, but we don't have P. So is there any way we can find out P for this neutron? Of course. So de Broglie wavelength is given as lambda equals to h upon P. So de Broglie in his famous PhD thesis proposed that as matter has as the radiation has the property of wave and particle, matter also must be having the properties of wave and particle. So this is the dual nature of radiation and matter. It was introduced in class 12, and we know that because the light had shown the property of interference, and light has also showed the photoelectric effect. So light has both the properties of particle type and wave type nature. So de Broglie in his PhD thesis proposed that because the nature does not take sides, so if radiation is showing the property of wave and particle both, why not matter? So matter already is known to have the property of particle. So de Broglie proposed that it has to have a property of wave also, and its wavelength can be given as h by p. So p is the momentum, h is Planck constant, lambda is the wavelength of that matter. Okay, so let's if we apply it, so we can write it as p equals to h upon lambda actually. So h is 6.6 into 10 to the power minus 34 by lambda is given as 10 to the power minus 10 meters. So it will just come out to be 6.6 into 10 to the power minus 24. Okay, units momentum unit is mass into velocity, so it would be kilogram meter per second. Okay, now we have to find out the energy, and energy can be given as kinetic energy can be given as p square by 2 mn. So we are going to put it here. So it is 6.6 into 10 to the power minus 24 square by 2 into mass of neutron is given as 1.67 to 10 to the power minus 27. So when we do this, so 6.6 1.672. Okay, so 32 6.22 6.66 in 6.6 into 2 coming out to be somewhere 13. So 10 to the power minus 20. So this is the energy which would be in joules. Okay, so we are, because we are asked to give energy in electron volt, so we will again do the familiar division, that is 1.6 into 10 to the power minus 19. So it will equal joule per electron volt. So energy in electron volt would be coming out to be 10 to the power minus 2, and it will be 13 by 1.6. So it will be 16 and 144, 16, yeah. So it is about 8 into 10 to the power minus 2 electron volt. Okay, so what we have done here is we have used de Broglie's wavelength formula, and we have also used, okay, so we didn't need the Heisenberg uncertainty here. We just use the energy formula that is given in terms of momentum and mass. Okay. So this question was asked in the last semester's final exam. So this is type of numerical that you would be finding in your final exams. So hope you practice these kind of numericals. Thank you.